So the first thing we have to address in your question is that you've got a slight misconception. There's a bit of confusion, and it's not really your fault. It's just that terminology in chemistry can sometimes be confusing. So we have to tease out the difference between heat capacity versus specific heat capacity, right? Or just specific heat. So specific heat does relate to the number of grams of a substance, okay? And heat capacity does not. So what you're saying is, well, okay, if I were to take some water away, well, it's still the calorimeter shouldn't have the same heat capacity because that doesn't vary by the gram. And the answer is no, because the heat capacity allows us to kind of get around the specific heat. So let me explain what I mean by that. And we'll just use water as an example. We know that the specific heat of liquid water is, depending on the textbook that you're looking at, 4.184 joule per gram degree Celsius. In other words, to raise the temperature of liquid water by 1 degree Celsius and 1 gram of liquid water by 1 degree Celsius, you have to impart 4.184 joules of heat energy onto that water. Okay, so if I have 100 grams of water, say, so here's 100 grams of water, well, I can just establish for this whole group, this whole object of water, it has one heat capacity, right? So long as the amount of water doesn't change, then it's going to take 100 times 4.184. It's going to take 418.4 joules per degree Celsius for the whole block. And that just comes from the specific heat capacity. Again, the specific heat capacity varies as the mass, right? If I increase the mass, then of course the heat capacity is going to change. And let me phrase that again just to be very clear. The specific heat is based on the substance itself. So if the substance is the same, the specific heat doesn't change. But as I add more mass, I'm increasing the amount of mass that is subject to that specific heat. So if I have 100 grams, the heat capacity of that block of water sounds dumb if it's liquid, but that aggregate of water is 100 times what it would be for just 1 gram. If I had 1,000,000, it would be 4,184,000, etc. So the specific heat doesn't change, but the heat capacity does depend, at least initially, to calculate it on the amount of stuff that's there. Now your question is, well, all right, let's say I've got all of these items here. Now, this metal has a particular specific heat. This thermometer, the glass, has a specific heat. This wire filament has a specific heat, and so on and so forth. But once I take the whole object together, assuming that that object doesn't change in any way, I take this whole calorimeter, I can basically say, forget about all the little specific heats. Let's just see how much energy it takes to change the temperature of the whole calorimeter, right? And that takes into consideration all the specific heats of the substances and the amounts of those substances with which the calorimeter is made. So if I find, let's say, that the specific heat of the whole calorimeter is that it takes, say, 1,000 joules to raise its temperature by 1 degree Celsius, well, that is for one specific calorimeter that has a certain amount of metal and a certain amount of water. Well, if I take some of that water away, let's say I take that chunk of water away, well, now I have to recalculate the heat capacity, because notice if I took water away, when I were adding heat to the calorimeter after I've removed the water, I don't need as much heat because I don't have to change the temperature of this water, okay? So because I've lowered the mass of the water within, and water, of course, has a constant specific heat, right? Because I've lowered the amount of water there, the heat capacity of the water within is lower, so the heat capacity of the whole thing is lower. You can think of it like this. If I want to heat up, a cup of coffee, it doesn't take that much heat. If I want to heat up a bathtub, it takes a lot more. If I change the amount of water, it changes the amount of heat necessary to change the temperature. Specific heat is the same, heat capacity varies as the mass, as the amount.